Hi, and welcome back to part 3 of this series about tensegrity and the PretensT project. The twist is the simplest tensegrity module. 3 struts pushing outwards, restrained by 9 cables pulling inwards. But to really understand what it is and how it fits into tensegrity, I'm going to have to build one for you. We're going to need 2 different tension lengths, 3 long cables and 6 short ones. To make the tension network, we'll need 8 rings where the cables come together. First, we build the top and the bottom of the twist using the short cables. Each of these is 3 radial cables connected to a central ring. Then, between the top and the bottom of the twist, we will need the long cables with rings attached at their ends. Finally, the long cables are all tied to the loose ends, and it all connects together. There we have it, tension complete, the tension of the twist. But of course, tension is nothing without compression. So now, for the struts. As you will have seen in previous episodes, our struts have adjustable length. So we make them as short as possible before we insert them. The first 2 struts are easier because the structure is still flat. But the magic happens when we insert the 3rd strut and the twist starts to take shape. It starts out loose because the struts were adjusted to be short. So now, by turning the nuts, we lengthen the struts and tighten the whole tensegrity up. And now we have the twist. But the twist has a direction. It's called chirality, which can be either left-handed or right-handed. This twist seems to spiral counterclockwise towards us, which means that it's a right-handed chirality. It's easy to test this because it seems really natural to grab the struts with your right hand, but it doesn't really give you an easy way to do that with your left hand. So, if this is a right-handed twist, there must be a left-handed one as well. It's built from exactly the same tension network, and only the struts are inserted differently. Ladies and gentlemen, the twist sisters. As you can see, the left twist and the right twist are mirror images of each other, just like your hands are. Now, these are clearly 2 separate tensegrities. Each twist has its own integrity. But with the fancy PretensT adjustable struts, we can loosen them up and try something else. Take a close look at how the ends appear and how they might nicely fit together. Now, think of a regular hexagon where all the line segments are the same length. So, the radial cables at either end of the twist can instead become part of a hexagon of tension. And this hexagon can become the place where 2 twists come together as one single tensegrity. Let's do it. So the first thing we have to do is disconnect the radial tension by undoing the knots holding the cables to the central ring. When both radials are disconnected, we can use the loose ends to create a new zigzag ring of tension, which will soon be stretched into a flat hexagon. This is now a single tension network, made from the original 2 separate networks of the twists. We now have to bring back the struts, and from the 2 twists, we now have 6 struts to insert. There's nothing about the tension network that requires us to make a twist left or right-handed. That all depends on how exactly we insert the struts. This is the tricky part, because we want the two twists to be left and right-handed again, just like they were before. Okay, the struts are there, but the tensegrity is still loose. We lengthen the struts by turning the nuts, and that tightens everything up again. There we have it. Two separate tensegrities have become one. And now you can see the hexagon of tension around the equator of the new two-twist tensegrity. Do you want one of these? To get a feel for tensegrity, you really need to have it in your hands. If you like, I can build one and send it to you. If you want to give your hands a treat and support this project a little, visit getpretenst.com and place your order. Whether you use tensegrity to learn or to teach, or just for decoration, you'll have them around for reference for years to come. In the next episode, we'll build a whole tower of twists, and I'll show you how it kind of acts like a spine. I hope you can join me.